like engineering communications or whatever. So it's basically like writing and sciences, but for engineering. Professor, and she has blue hair too.
Bro, this is fire.
Did you find one?
There's just tons. These are too like fashion-y for me. I need like I am a secret agent.
Yeah,
I mean,
yes.
Like you carry around a sword.
Yeah, it's like hidden, like.
that's fire.
Wow, yeah,
Like
sun
I
dial.
want this to be my constant vibe. That's
Yeah.
That looks like Evan to me. That like screams Evan for some reason.
Evan.
Okay,
This
something,
is our quiz.
not yet, but there will be, there is.
Oh, sign up for.
Yeah.
Monday, is that next Monday, Dimitri?
No, it's
already?
two.
It's what I want to discuss. When do you like to
Can
present?
I get one?
Do not say never.
Well,
Can I have one?
Oh, yes, yeah, you were
No.
even between.
Let's take a look here. We don't have,
Theory.
when's our next test in analytical?
actually, Monday the 7th is kind of a good day to do it.
Alternative is the
Right.
Friday before that.
Oh, the Friday before that?
I would say Monday.
Monday,
Yeah.
because then during the weekend you can.
Monday this not this Monday. Oh,
No, that's 2 weeks.
analytical is on the 16th.
So it's that's a Wednesday.
That's
Yeah.
like the first-
Why do you have to put add theory?
What?
Why do you hot theory? Hot theory.
Hard theory?
Yeah, like
Because other theory is so easy.
this, like
So
particularly.
that would be the,
Oh, so they're like difficult periods.
Oh, okay.
Nobody's gonna wanna do that one.
so that would be the first Monday of November.
Yes.
I'm not gonna be here.
I was watching.
I was
watching.
Then we should do it on Friday the fourth.
I could just,
Are terrible.
like, give my little presentation of
Three
Wednesday
People went out
after.
in like the first like. 12
Do you
hours.
guys?
Earlier is okay, later no.
Oh, man.
So Friday the 4th?
One side of flag.
Yeah.
I mean, it's only, what, 2 days earlier? It's not
Yeah.
like,
Not Louis.
okay.
Anyone else?
Are you guys listening? We have to do it on Friday the 4th.
Why?
Because Frederick's not gonna be here on Monday.
Right, no. Fred does it on Friday, we do it on Monday.
Yeah,
Oh.
Fred can do it early and we can do it on Monday.
Yeah, we're not gonna.
We
be-
didn't think about that.
It's only fair.
I want to be sharp and hard and rigorous. But I do not see, I cannot find a reason why it is not possible. I'll try to find one.
I think it's fine if we just all do it on Friday. I don't speak for everybody, but,
I'd like Monday.
okay, sorry, just kidding.
I like the idea of us doing it on Monday. Yeah, Friday, because additionally, we
I'm sure
usually
you
are
do.
like,
Yeah.
we're always like pressed for time at the end. when we
That's
all go.
true. We kind of
And so
run
now
out of
we'll have a
time.
bit more time where everyone can go and ask questions.
We can prepare ahead of a week ahead.
No, not run out of
Oh,
time
you
to
need to-
complete it, run out of time to present. And so if one person presents early, then we have more time for everybody else to present on Monday,
Oh, I see.
It's different.
which would actually be kind of beneficial.
Practice.
I don't see any serious objections from my side, but
Quality rate.
for some reason I like when everyone presented the same day.
Yeah,
It's kind of more.
It's just nicer to
visual
everybody.
Inspiration.
Yeah. we're all in the same boat, so we all have to do it anyway, so.
And
We're all
Patricia,
together.
will you present?
One, two,
Team on
Three.
3, 1,
One,
2,
two,
3, team. Minus Fred and Patricia and Melody, sorry, guys.
they were there in.
Team.
Right, Fred.
Yeah.
Okay, so,
Yeah.
please read the subjects and by the end of the meeting distribute.
We have to cover all of these.
Yes, for sure.
Oh,
I do not want to do movies, I can never get
No,
that
give
one.
that to
I can
me.
never figure that one out.
Melody did movies.
Visualization and movies should be one subject. And then we have 6 subjects and 6 people,
2, 3, 4.
right?
Yes,
Okay.
I'll do.
So these are what?
You can think, discuss and let me know by the end of the class.
By the end of the.
Dimitri was
Wait.
What?
WP?
Wait,
Oh, white packet.
Okay,
Wait, packets?
wait, packet.
How do you
So
know?
Fred, you can do that one.
Packet.
Just a lucky guess, I guess.
Wave,
Wait,
I
really?
don't have anything else, wave.
Washington
wave-
Post.
Yeah, well, I mean, I've
Washington
heard,
Post.
I've heard, wave packet a lot, I just
What's
don't know what it means.
Yeah, like this packet of papers.
It's like wave function square.
Can I do visualization in movies?
No.
Yeah.
You decide between yourself, I don't care.
Well, we're never getting.
No, Fred, you have to do movies and applications because you knew what WB
No, he
meant.
said,
No.
you said visualization and movies. is
No,
one
Fred, you
subject,
have to do
right?
visualization, movies, applications, and properties of.
Fine.
And get a salary of instructor.
I'll,
So are these,
I'll
this
do
is on
properties of
MATLAB.
operators, I guess.
Can you
I can
select
do
one piece of paper and write your name so I can,
Is this on MATLAB, Dimitri?
yes.
Yeah,
And Mr. Clark?
I can do numeric.
Oh,
modeling.
no.
Right, Fred's down, Fred wants to do these. Do
Melody is here.
you want to do these, Fred?
Sure.
Hi, Melody.
I guess.
You actually?
Yeah, well, I don't want to do any of them. Yeah.
Hey, bestie.
You know, for that.
Okay. Well, I don't want to sign you up if you don't want those,
Do you have a microphone?
because we did last. time.
Huh?
Because we did last time, we decided.
Yeah, that's all right.
Ava, do you have a preference?
I haven't read these.
Hello, Melody, do you hear us?
Hello?
Hello, hello.
These are all.
Test, test. Everyone is waiting to hear Melody.
Yes.
Yes.
Can you, oh, it's good. Can you speak that we hear you? Does your
I'm
microphone,
gonna go through this, the last. Yeah,
Oh,
locations.
I don't know how to do that
until
either. I don't know how to
last.
do that. Yeah. She said she
We like
forgot
this.
to turn audio on, but
okay, so in addition to some boring mumbling of lectures, we do have two things to decide together. One, to select who will be presenting on Friday, November 4th, or maybe next Monday.
Yeah.
I didn't learn what is a majority, but we need to distribute subjects.
We haven't really done.
And Melody, if you do not raise your voice, there is a chance that there will be subject not taken by anyone else will be to you. So we need maybe someone to serve as your agent.
First theory.
difficult theories.
Oh, she's typing something and but chat. I forgot to turn my audio on. I've chosen first a few times, so I don't mind getting last pick.
Dimitri, what's hard theory? Hard
Commu-
theory. So that's like the hardest option.
Well, there's only two.
No, it is.
No.
It's not the hardest option, but it is least connected to practical things, to practical applications. It's more like foundation, abstract foundations. It's good. It will be it. Let me speak positively. Whoever selects hard theory will pump mathematical muscles and will be stronger in answering questions of unbiased audience. But it will be not a big help towards doing actual applications. From year to year, I am trying to send invitation to the whole department, but at final presentations, but typically only like a couple of people are showing up. And from year to year, the questions are not about the subject of whoever selects which applications, but always about foundations. I'm a little disappointed because I think students do really good discoveries, and visitors still like, how can you prove that the method is correct? Blah blah blah.
Mhm.
So hard theory is related to this thing.
Okay.
Did anyone selected the applications?
I did.
You did, and Melody competes for this.
Oh.
So let's talk to her. It's not my responsibility to mitigate
That's
your
okay.
We're like running out of
who running out of subjects. Which subject?
asking.
Which subject? Melody, okay, let's run on the common paper that Melody competes for the last subject. And Melody, what is your second choice? Let's do like first, second choice, and then I will.
I don't know if she can see the assignment sheet.
I did send it. I did send it to everyone.
No.
Okay, so I will collect it by the end of the meeting and hope to see some. What has been chosen already again? Melody, it looks like you are making myself your agent. You need to select someone from the class who will communicate idea to you. What is selected? Let's
Do hard theory.
let's bring it to the camera. Melody, do you see it?
Next week.
Okay. Let's consider it is half done now. Next thing.
Either, okay, so then.
Surprise.
Theory is, but she said, yeah, what?
Oh, she agrees to hard theory and no one else wants to take it. Okay. Melody, thank you for cooperation. It is much appreciated by class members. For me, it's less important, but I think everyone likes that you agree to take hard subject number 2. Now, thank you so much. I really appreciate this level of cooperation. So you have something to write with. Let's do a surprise quiz. It checks how well you percepted the content of the Friday's lecture.
Oh, that is surprising.
That is.
Yes.
Hold on, so you have it.
Sitting on the table.
And Melody, you do have this quiz with you on in electronic form. So I will start. You don't need to rush. You can do it in about 15 minutes, because I'm going to show slide with the answer key, and then after that it will be useless. Right?
It's super fast. We don't see it.
The share screen.
Coming to you.
Okay, so you already selected something to present. There is another homework due next week, but it is super easy. I just do not want to give you surprises and additional stress, but you could do it even by the coming Wednesday without any effort. It's really easy, but let's just do things slowly so that you can plan your time. And it accompanies like maybe this next couple of lectures. So there is no doubt that you can do it perfectly. This is much easier, like maybe 4 times easier than the previous one. I even do not know, should I increase credits for the previous one or decrease credits for this?
We all get 2 points extra credit for doing the last one.
So what is on this diagram? What's the right way to say? Thank you for your fairness. But is there anything in addition to the lines? Huh? But how would you? Oh yes. You know, my goal is to eventually bring quantum theory to the kindergarten, right? So exactly. It shouldn't be stress. It should be easy, and I want to just
For annihilation. 1/1/2. Yeah.
you need to select. And
Annihilation operator. Yeah. I like it.
I want to go to the level when one can complete this little tasks, even being illiterate, just by drawing lines, pictures. So anything valuable in this lines as Sam described them?
No. No.
Thank you.
Atlas. Evolution operator.
So what are the axes? And how does it deal with content of our course?
Methods, the x-axis is
Like
methods.
the quantum states thing, 'cause it's the methods, models, and.
Yeah, method models and what is that?
External perturbation.
Interpretation.
Extra.
Perturbation. Perspective, if you would be in the art department, yes, perspective as a way to visualize three-dimensional things. Okay, so what's the name of our course?
TCAM.
There said 2 for application.
1,000 methods and
It's an application.
now
Now we have 3.
now we have 3. So on the x-axis there are 1,000 methods, and on the y-axis there are 3 applications.
Yeah.
And now we deal with harmonic oscillator. Last time in the class, someone was telling harmonic swinger. And in addition to old methods, last time we added a concept of ladder operator. What's ladder operator?
It's the what?
Ladder
Operator.
operator.
EIO.
Is it just one that goes, oh, you're asking for like the letter?
Ladder operator, like you started answering correctly. Just keep going. What you
I was describing it.
Mhm, yeah, please do.
It just goes like stepwise, like if it's a ladder, like
Mhm.
it would just jump from one value like to the next.
Mhm.
It's
Or-
values.
Yep.
What's the
That's all I got.
That's it. You don't need more.
All right.
And they can be expressed algebraically. Why do we need them for harmonic oscillator? They do. Oh, maybe Fred or Eva or Patricia can answer.
What's the question?
Yeah, we will.
Answer anything. Are there any benefits from ladder operator based on what we discussed on Friday? Is it the only tool to torture young minds, or there is any benefits
I'm sure there are.
other than above mentioned one?
Some.
Did we talk about ladder operator on Friday?
I hope so.
Oh, maybe I just didn't know.
Do you remember Robert Dmitry?
Yes. Oh, yeah, silly.
Oh, now I see who wasn't watching the recordings.
Yeah, silly robot Dimitri. He had 2 options to go up a step. Is this what we're talking about? Up a step or down a step? And let's say there's like 5 steps and you tell him, yeah, go down 7 times. He can't because there's 5 steps. So then he like malfunctions or something.
Okay. Where is that?
Is it beneficial? Is this malfunctioning robot a mathematical benefit to anything?
No.
Any opinions of those who are aware of the Friday material?
Is what? Is robot Dimitri helpful?
Does it bring any mathematical benefits to the subject of that we covered?
I guess you would easily be able to like set limits. And like,
Based on Friday, we talked about, what I can remember from Friday, we talked about how, some, applications can be used with simple, kind of solved using simplified, version of Schrodinger equations, where then we have to use some complex, not too complex.
Good. Probably to those who didn't listen to Friday's meeting, it is not very helpful, but I see connections and I see how it is built up on what we discussed. So please consider to watch Friday slides or if time allows, fast forward on the discussion. We were mumbling and discussing fun stuff for 40 minutes and then going over 70 slides in 5 minutes. But discussion is more important than slides. Briefly, atoms inside a molecule, or ions inside molecules oscillate. And the interatomic distance is a probabilistic. It can be shorter or longer, and one can write down a Schrödinger equation for interatomic distance. And then the Schrödinger equation needs to be solved. The equation is more complicated than we had before. It has a mathematical challenge, and standard things to solve Schrödinger equation for harmonic oscillator, which is just one internuclear mode, is. What should one kind of connect? Standard way to solution is to represent a known function in the form on infinite series with a known coefficient and plug it in and then solve for coefficients, which is correct. You all can do it, but it just takes longer time. And there is a shortcut. Ladder operators are allowing to get the same solutions in a little, maybe 10 times quicker, maybe 5, but definitely quicker. So it is just a tool to get solutions of Schrödinger equation for harmonic oscillator, which represents nuclear vibrations. And later on, we will use ladder operator also for NMR and EPR and like magnetic spins. One of the questions to the next homework will be requesting you to give examples of harmonic oscillators. Like if you have a molecule with several bonds, they like normal modes, different bonds contract and expand, and you all know what is FTIR, right?
Yes.
Okay. So it gives frequencies. In addition to most natural way, there are librations. It's not motion of students towards library. It's motion of the polar solid molecules around solute molecule by changing angle. Another most fun example is you'll carry cell phones, right?
Yeah.
So it is transmitter and receiver of radio waves.
Yeah.
What's the connection?
Like walkie-talkie.
Walkie-talkie, yes. What's a connection of walkie-talkie and this little image? I know that I cannot pronounce it right. Walkie-talkie.
That's pretty good. I don't really know what walkie-talkies do, to be honest.
Well, and radio waves.
Physically, I know like what they do. I don't know how it works.
Yeah.
So it's like physics 200 question.
But we never took a physics class above one.
Too bad for you.
We did.
Oh, you're right, we did.
We're just talking about taking physics too.
So can you read this diagram and tell how does it deal with radio waves?
Oh, it's like a circuit, no?
Oh, yeah.
I haven't taken 252 yet. don't
I
know
took
how it
252
goes.
and it went,
It's a circuit. Positive on one end. And
Anyway, you are much more educated than myself because you just missed some concepts by taking physics courses. And I didn't have any chemistry courses at all.
so.
I don't know what that little like light out of it is.
So when there are two plates, what does it symbolize?
Two, like, one side's positive, one side's
Battery.
negative.
Yeah, but each element of the circuit is something that you can solder in.
Yes.
Yeah.
So which element is corresponding to these two plates?
Copper element, or like an actual chemical element?
Be patient, cool down, be patient. Not chemical elements. Element of electronic circuits.
We took it too.
So it's like a battery?
Battery if the plates are not equal. If one is shorter and another longer, and if they are equal, which elements of circuit do you know?
I don't know anything about.
No, you do.
No, I haven't taken.
You have, well, if you have a circuit, you're gonna have,
No excuses.
oh my God.
I haven't taken it.
Can I phone a friend? I'm gonna call.
I don't know what, if they would be, if they were equal.
Uh-huh.
Like,
About names of the elements, not chemical elements, but circuit elements. Did you watch Back to the Future?
it could be,
Fiction?
Yeah.
When it,
Oh,
flux what?
Oh.
Capacitor.
Capacitor. So you know this element.
Oh, okay.
Okay.
Here it is.
I
Capacitor is a device that stores electrical energy in an electric field.
perfect.
Thanks, Jerry.
Huh? Science fiction rules. Okay, what is and is typically used with letter C. C capacitor or
Cool.
what is L? Or what is by this curly hair, not hair.
chopped it out
Lunch.
much.
Do you ever broke ancient radio like?
No, you're really dating yourself here.
That's not that's not a stolen way to.
Like go to the garage, find some like
A big boom box.
100 years old and broke it on pieces and look what is inside.
Have not done that.
There are radio lamps which like flash red if it is working. There is a capacitor that looks like many plates coming to each other this way. And there is a
No, I sent a message.
Melody, if you would, if any of you need ever join Zoom, voice is preferred, but
It's an inductor, right?
yes, Melody, many things. Although I prefer voice much more than text, but you're absolutely correct. Thank you.
You said it.
It says it too, right there.
Oh my God.
I know that for this class, you do not need to be illiterate. And you took it literally by not reading things. Okay, so inductance, capacitance. Now,
I really said the answer the whole time.
Hey, none of us picked up on it.
That's upsetting.
okay, so ever told what definition of capacitor? What is the definition of inductor or inductance?
An inductor is, I guess, induction is something that's able to like ultra, right? I might be mixing up my definitions. It's been.
So can you do inductor yourself?
No.
You can.
Yes. you're
You
right.
just find a wire and coil it many times.
What's the difference between conduct and induct?
Induct.
Conduct.
Like you conduct electricity, a conductor.
About in 5 minutes, I need to go to slides and flash through them quickly, but I think we enjoy chatting more. Let's ask ourselves a philosophical question. Induct what?
Current. Electrons.
Energy.
Very good players.
What about Biot-Savart Laplace ampere law?
Say that one more time.
I did impress you.
Uh,
Okay, if you have a coil with a current, what does it induct?
Charge.
What unusual? What thinking out of box?
Magnetic field.
Here is
Magnetic.
who of you did EPR or NMR? Have you seen EPR in?
NMRs. I've never.
Okay, have you seen like big discs?
Yes.
But he asked for EPR.
Teach all of us about these big discs.
Oh, God.
Chemistry to physics
Well,
connection.
Within within NMR, you have two like really strong magnets, and I guess I'll more describe what I do know. But in order for like NMR to work, I know that to take these magnets, you have to basically take liquid, really helium, you have to cool them down. I don't exactly why. I know that if you have a cold magnet, it kind of creates you create a vacuum down. And so doing the NMR. I don't know. That's kind of all I really know when it comes to the magnets. I know it has to be the vacuum, it has to be cool. I mean, it spins really fast and it can really mess with like pacemakers and stuff.
Like really strong magnetic field, if your sample is placed in there, don't the atoms or the spin of the atoms like align either with or against the magnetic field? And then like with the NMR, like as you are blasting you with radiation at certain frequencies, it'll like it's spin and it'll like orient itself the other way.
Truly cool, but doesn't answer my question. Sorry. So, if you do not use your NMR or EPR instrument, can I come there with my keys? And like, if it is working, it will full keys. And if I have it on the next, it will probably
No more.
kill me, right? But can I approach the NMR instrument when it is off? So what changes when it is on and off?
There's charge on your when it's on.
So what is inside these magnets, electromagnets?
A conductor.
Coils. So current needs to go through the coils to create what?
Magnetic field.
Okay. So what?
NMR is on and running.
Okay. So what is inductance? Element as an element of electric circuit.
Magnets.
Yeah, electromagnet. A coil that when current passes through it creates magnetic field.
Oh, so that is a coil that you drew.
It's not my poor calligraphy. It's common notation.
But
Okay.
that's sort of what it's.
Okay. Now, did you ever visited physics department?
Sort of.
Their common room with some little demonstrative experiments.
No, I've never seen that. I've been into the conference room on the second.
Oh.
Okay. Maybe you had it in the high school. If one creates a coil, connects it to like something that measures current,
Oh,
and then takes a magnet and like moves it in and out or nearby. What do you see?
Oh,
yeah.
you wrap the coil around something, then you move it up and down the magnet.
Doesn't it increase the charge as you
It was one
move it?
You have to wrap the coil around it, then you go like this with your.
So you're right in spirit, but wrong in terminology. Elsa, do you think everyone understood you?
I think so. I think they understood like what.
That's a solenoid, isn't it?
Good.
What
Okay.
the hell, Fred?
I took the class. Yeah.
Okay. So now we are justifying our name of physical chemistry. We will really have a little bit of physics. So the electric current passing through inductance creates magnetic field. Or if you do not have any current and just increase or decrease magnetic field inside this inductance, it will create a current, right? It is what you've told.
Yes.
Okay.
Because you're like building up static, right? It's not creating a current in the same way. You're just like generating static electricity in that.
Okay. Static electricity is okay, but let's be careful with terminology. Sam wanted to say the same thing, but he used the word charge. So charge and current are different, right?
Current increases, your charge doesn't.
So current is moving charge. In some sense, current and charge are like momentum and position. Charge is like position and current like, okay. Now, what about C, capacitance? If we try to pass, can current go through the vacuum?
No.
Intuitively, no. But what happens if you try to pass current through? If you're like, I'm putting a stream of electrons through the line that is closed. They will concentrate the electronic negative charges will concentrate on a plate, right?
Mhm.
And if I deteriorate the whole circuit with electrons, here there are no of them. So it's lack of electrons will be holes, positive charges.
Mhm.
So one plate is negative, another positive. What is created between positive and negative charges in the vacuum? Attraction, yes, and something like here is a positive, here is a negative. They do not move. And what is it? And what is between? Yeah, it's neutral, but what?
Your potential.
Yes. I know you know it. Let's assume you have big plus, big minus, and then little positive charge, and I put them in between. What would this little positive charge do? Why?
The positive side is already like big and filled up.
Well, no, it's because if you have two big of like the same proportions, right? The middle is gonna be 0. And then if you put a small, if you put a small like positive in the middle, it's gonna go towards the negative, because if it's neutral in the middle and you put a positive, it's gonna push towards that side.
So we all agree on this.
Yeah.
But now let's design a scientific concept. So we do not care where. Suppose we have several experiments where this little positive charge moves to the same direction with the same velocity, and we see that there are several experimental ways to create the same conditions. Like what will be the same in the vicinity if we do not focus on the charges, but we look on the little area of space. What we do have in this area of space where we put the probe charge? Which concept? You know it. I'm just surprising you by shocking you with an unexpected question.
So what concept do we have in the middle?
Yeah, what do we have in the middle? Now you're playing with words, as people do in linguistics, which is not bad. So charge is moving. Motion happens, acceleration if there is a like gradient of potential. So there is a potential, right?
Yes.
And if you take gradient of potential, there will be force. And what's the name of the force that acts on charges? If you divide force by elementary charge, what would it be? Like in all areas of space,
No.
and in all areas of space, there is a force that would act on the elementary charge. And now we divide amount of force measured in appropriate units like newtons, divided by elementary charge in coulombs. So newtons per coulombs is units of
Yeah.
Is it not?
It's not joules, it's not amps, it's not. No.
Okay, let's start over. I know that we are very late for another 40 slides. But moving charge creates magnetic field.
Yes.
And static charge creates
Static electricity.
good, but try again. Maybe Sam will help us by using linguistic skills.
Induction.
Moving charge on the induction creates magnetic field, force and field. Okay. Static charge.
It's a static field.
Which field, except in addition to magnetic, do you know?
Which field?
Like light is, what is light?
Light is a wave.
A wave of what?
A proton or no, electrons, yeah. Well, electronic field or electron field?
There are no electrons. There are no electrons from sun to us or from like flash lamp. There are no electrons coming through.
Photon.
Photon. Photon is a quantum of which field?
Electric field.
Electric field is the answer to here, and photon is electromagnetic field. Electric and magnetic field are connected, right? So electric field created between capacitor. I thought it is an elementary part that we were
Struggled with that one.
So if one creates this positive and negative, it creates electric field and charges do not go. Electric field moves opposite, so it pushes them to go backwards to restore original condition. And when it goes to restore original condition, current is going through inductance and creates magnetic field. Then the circuit becomes neutral, but there is a magnetic field. And this magnetic field, with time, it decreases. When it decreases, it creates additional current, like inertia, and it makes current to swap charges, being negative here and positive here. And then it recharges capacitor, makes it moves opposite directions, then charges induction, and then they go swing forwards and backwards. This is another example of harmonic oscillator. That's it. And it will be one of the questions in your homework. Give 5 examples of harmonic oscillator. Right? The frequency of this frequency of oscillations depend on the value of capacitor and inductance. And by changing capacitor and inductance, it is what when you tune your radio to different stations. So you change frequency by changing either capacitor or inductance.
So that all connects back to walkie-talkies though.
Right. I don't know. Previous years I was doing it much quicker. Probably I'm getting old.
Well, we're also really had a hard time with that. That was ours. Yeah, that was.
Okay. So 3 minutes for 40 slides.
Yeah.
So here is equation, and this R square is a bad guy that makes our life happy. Here is time to collect your. Okay. Thank you.
Whoa.
Yes. Anyone? Melody, please send your work by email.
Write down what one I was doing. If I did application.
Oh, my,
Did
yeah. I took a picture of it.
Done.
I'll send it.
Okay, so
Melody sent this.
okay, send by an email. So 1/2, 1 here, m omega, and then the remaining thing goes here, right?
Yeah.
So what is the reason, what is meaning of this annihilation operator? It is a linear combination of position and momentum. Here in another way. And when it acts, let me go, there will be always impossible. Yeah, I need to draw. Do you have next class, right? So I need to speed up, really speed up. So when one applies, suppose we have quantum states, yet unknown, annihilation operator makes transition from upper state to lower state. Creation operator makes transition from lower to higher. And by trying to go lower than the lowest state, one gets an equation and finds the ground state, which is same as Gaussian. Here is the inverse width. We do need to obtain state number 1 in the remaining 30 seconds, right? So in order to do this task, so here is the answer. So we need to go from phi naught to phi 1, right? What is their difference? Let's look once again.
Ground state versus excited.
This is linguistics, names, and mathematical, what is the difference? Look on this, and then on this.
That's a 2 and the first one was a 1.
Yeah, anything else, anything substantial.
There's the,
I can't remember it.
I wish I had a photograph.
yeah, it's. Hold on, there's the M and W too.
Okay, so phi naught is NE minus M omega
H, just H.
what? H bar to the top or the bottom?
on the bottom and
Okay.
then R squared on top.
R squared. Now, the creation operator will be the same as annihilation, but minus changes to plus, right? So I just use your answers as a cheat sheet. So will be square root m omega h bar, m omega position, and minus I p. So p must be replaced by minus I h bar d dr. And if we apply this a dagger to phi naught, we will see the following thing. From the first term, you multiply the e minus b r squared by m omega r, right? And from the second term, you have e minus r squared ddr, right? What is the ddr of the exponential? I'm skipping all things just to have it quick. This is the only thing after which we will depart in peace. So this is unavoidable.
-2r
Negative 2r.
and times the e to the negative r squared.
Okay. And by carefully taking into account all these constants, we will find the constants will be the same. And we will have these two terms will add together, and it will be coefficient r e minus r squared. Now, if the e to the power minus r squared is a hump, right? If you multiply it by a linear function, it will become 0 at the 0, and then it will become negative here and positive there, right?
Yeah.
So this function with one nodal point and two humps is a phi1 first excited state of the harmonic oscillator. Same as for particle in the box, it has two humps and one nodal point. Okay, done. Looking forward to see you on Wednesday. Thank you for votes and the quiz. Huh? I already got it.
Okay.
I printed more copies so that you can look on them and remember what you have selected.
I certainly.
You are looking at a man who got 100% on his inward.
Oh, okay.
Yeah.
Good, oh my God,
Congratulations.
that's so good.
Fred, that's epic.
How much?
We're proud of you. It'll be fine. Bye, Dimitri. See you on Wednesday.
I'm just out here just like.